Persist the DB, the database. In case you didn't notice, our to-do list is being wiped clean every single time we launch the container. Why is this? Let's dive into how the container is working. And by the way, you can get this information in docs.docker.com slash get started slash 05 underscore persisting underscore data slash. The container's file system. When a container runs, it uses the various layers from an image for its file system. Each container also gets its own scratch space to create, update, remove files. Any changes won't be seen in another container, even if they are using the same image. See this in practice. To see this in action, we are going to start two containers and create a file in each. What you'll see is that the files created in one container aren't available in another. 1. Start an Ubuntu container that will create a file named /data.txt with random number between 1 and 10,000. So we're gonna pretty much we're gonna copy. So we have Docker space RAM space -d space Ubuntu space bash space -c and quotation marks shaf space -i space 1 -10,000 space -n space 1 space -o space /data.txt space $% space table space -f space /dev/null. So we go to Visual Studio Code and we make sure we are in the folder getting started and we are inside the folder named app. So we paste it, Control V. So we press enter. Okay. In case you're curious about the command, we are starting a bash shell and invoking two commands. Why we have the $%. The first portion picks a single random number and writes it to the /data.txt. The second command is simply watching a file to keep the container running. 2. Validate that you can see the output by accessing the terminal and the container. To do so, go to Containers. In the Docker desktop, hover over the container running the Ubuntu image and select the Show Container Action menu. From the drop-down menu, select Open in Terminal. So we go to our... and by the way, in the previous video, we create a Docker ID. So you have to create a Docker ID. You go to that link and hub.docker.com, and then you link it with your Docker desktop. Mine is here, test app pjs. So right now it says Ubuntu, okay. So the indications were hover over the container running the Ubuntu image. So hover over the container, we go to the desktop in Docker and we hover over, this is the Ubuntu, and we go here, show container actions, good, and then we go to open terminal. And yeah, this is the external terminal, or you can also have the integrated terminal. I think you have to go to settings and you can use the integrated terminal or the system default. The system default is gonna pop out an external terminal outside of the Docker desktop. If you choose the integrated terminal, apply and restart, when we hover over the Ubuntu image, we go to open terminal. It's gonna show us inside It's gonna be a terminal, but inside of the Docker desktop. So what they want us to do? Okay, run in the Ubuntu image and select the Show Container Actions menu. From the drop-down menu, select Open the terminal. Okay. You will see a terminal that is running a shell in the Ubuntu container. Run the following command to see the content of the /data.txt file. Close the terminal afterwards again. Okay, so we go and we type in cat space dash no space slash data.txt and we press enter. Okay, 785. Okay, if you prefer the command line, you can use the docker exec command to do the same. You need to get the container's ID, use docker ps to get it, and get the content with the following command: docker exec container ID cat. Okay, see, if we go to Visual Studio Code, we need to get the ID. So if we go to the containers, we have the Ubuntu image, and this is gonna be the ID, the Docker, the ID, the container ID. But if you wanna get it from the Visual Studio Code, you just type in docker ps and make sure you are inside of the app folder. So we press enter, and it has to be Ubuntu here, Ubuntu. So it's gonna be this one. So it's gonna end in C50. Let's see if it's the correct one. Yeah, it ends up in C50. So we can do that. We can use Visual Studio Code, and we can grab the where it was Ubuntu. So we grab, this is the container ID. Yeah. Okay, Control C, and we go to, let me see, docker exec. Okay, so we type in docker exec, and then the container ID, that is, okay, this one, and then space cat space data.txt. Let me see if it's correct. Okay, and we press enter. Okay, and you should see a random number. So yeah, that was a random number. So docker exec, the container ID, cat / data.txt. Okay, number 3. Now let's start another Ubuntu container, the same image, and we'll see we don't have the same file. Okay, we are in the app. We're gonna clean it up a little bit. CLS, we're gonna make it a little bit smaller. Yeah, we need to close this. And docker run, well, we can type it in. Let's stop being lazy. Docker, okay, docker run it Ubuntu, it space Ubuntu, and then ls space slash. Okay, we have bin, deb, home, lib, and proc var. Yeah, we don't have it here. And look, there's no data.txt. See, there's no data.txt. Okay, there is no data.txt file there. That's because it was written to the scratch space for only the first container. 4. Go ahead and remove the first container using the docker rm space -f, the container ID command. So we're gonna clean it up, CLS, and then docker remove So we put docker space rm space -f and the container ID. You can get it using docker ps, but since we already did it here, we're gonna just grab it from the docker desktop, and here we have, so docker space rm space -f space the container ID, and then we press enter. Okay, the container volumes. With the previous experiment, we saw that each container starts from the image definition each time it starts. While containers can create, update, and delete files, those changes are lost when the container is removed, and all changes are isolated to that container. With volumes, we can change all of this. Volumes provide the ability to connect specific file system paths of the container back to the host machine. If a directory and the container is mounted, changes in that directory are also seen on the host machine. If we mount the same directory across container restarts, we'd see the same files. There are two main types of volumes. We will eventually use both, but we will start with the name volumes. Persist the to-do data. By default, the to-do app stores its data in a SQLite database at /etc/todos/todo.db in the container's file system. If you're not familiar with SQLite, no worries, it's simply a relational database in which all of the data is stored in a single file. While this isn't the best for large-scale applications, it works for small demos. We'll talk about switching this to a different database engine later. With the database being a single file, if we can persist the file on the host and make it available to the next container, it should be able to pick up where the last one left off. By creating a volume and attaching, often called mounting, it to the directory the data is stored in, we can persist the data. As our container writes to the to-do.db file, it will be persisted to the host and the volume. As mentioned, we are going to use a name value. Think of a name value as simply a bucket of data. Docker maintains the physical location on the disk, and you only need to remember the name of the volume. Every time you use the volume, Docker will make sure the correct data is provided. So 1. Create a volume by using the docker volume create command. Docker volume create to do. We're gonna again clean it up a little bit. Okay, let's stop being lazy and type it in. Docker volume create, docker volume create to do -db, and docker volume create to do -db. Okay, stop and remove the to do app container once again in the dashboard, or with docker remove -f id, as it is still running without using the persistent volume. Okay, we go to the docker desktop and we go to the image, docker id, where was docker, started docker. We have to go to not in containers but in volumes. So here it is. We need to stop and remove the to-do app container once again in the dashboard, or with docker rm, docker space rm space -f, and then the id, as it is still running without using the persistent volume. Okay, we can do it from here. delete forever. So let's make it a little easier. And then number 3, start the to-do app container, but add the -v flag to specify a volume mount. We will use the name volume and mount it to slash etc slash to-dos, which will capture all files created in the path. So we go to Visual Studio Code and we type in docker space run space -dp space 3000 colon 3000 space -v space to do -db colon slash etc slash to do's slash getting started. Okay, and then we press enter. Alright, once the container starts up, open the app and add a few items to your to-do list. Let me see, do I go to localhost 3000? Let me see if it's running in the containers. Yeah, I mean, it has to be running. Yeah, getting started latest. Okay. Once the container starts up, open the app and add a few items to your list. Yeah. What is finish the workshop, do amazing things, be awesome. Sleep early, eat plenty, drink water. Okay, once the container starts up, open the app and add a few items to your to-do list. Okay, yeah, I did that. Stop and remove the container for the to-do app. Use the dashboard or docker ps to get the ID, and then docker rm space -f ID to remove it. Stop and remove the container. Okay, so pretty much this is the container. We're in the containers and the name is getting started latest. So we can do it the easy way and just delete it from here, delete forever. Okay, and right now we go remove it. Okay, let me see if I refresh it. Yes, alright, it went. 6. Start a new container using the same command from above. Start a new okay, we're in number 6. Start a new container. Start a new container. Start a new container using the same. You should see the item you're stealing. Start a new container using the same commands from above. Okay, so we're gonna start it again. We go to Visual Studio Code, we clean it up a little bit. Again, the same thing. Docker space run space -dp space 3000 colon 3000 space -v space to do -db colon slash etc slash to do's space getting started, and then press enter. So right now we are in number 6. Start a new container using the same command from above. 7. Open the app. You should see your items still in your list. If we go to the Docker desktop, all those items that we put in, they shouldn't have disappeared. They should be the drink water, eat plenty, go to sleep early, and we click here. Oh, and yeah, they stayed, they persisted. Good. 8. Go ahead and remove the container when you're done checking out your list. Okay, so again, we remove the container. This is the one, so this is the easier part. I'll show you how to do it through the Visual Studio Code. It's not that difficult, but it's just a little bit more tedious, so you just go here and delete. Make sure that that is the one that you want to delete, In this case, I know the image name is getting started and the port is 3000 colon 3000, so I just delete it. Okay, so you've now learned how to persist data. Hooray! Okay. While name, volumes, and by mount, which we'll talk about in a minute, are the two main types of volume supported by a default Docker engine installation, there are many volume driver plugins available to support NFS, SFTP, NetApp, and more. This will be especially important once you start running containers on multiple hosts in a cluster environment with Swarm and Kubernetes, etc. Dive into the volume. A lot of people frequently ask, where is the Docker actually storing my data when I use a name volume? If you want to know, you can use the Docker volume inspect command. Okay, Docker volume inspect command to do list. So we go to our VS Code and we type in Docker volume inspect to do. So Docker volume inspect the to do hyphen db. Press enter and I throw out this JSON, open brackets, open curly braces, create that. You have the time, driver local, labels null, mount point slash bar slash lib slash Docker slash volumes slash to do hyphen db slash underscore data, name to do db options. Okay. The mount point is the actual location on the disk where the data is stored. Note that on most machines you will need to have root access to access this directory from the host, but that's where it is. Accessing volume data directly on Docker desktop. While running in Docker desktop, the Docker commands are actually running inside a small VM virtual machine on your machine. If you wanted to look at the actual contents of the mount point directory, you would need to first get inside of the VM, the virtual machine. So yeah, I mean, this we succeeded in writing this code and making sure the application, the database persisted.